Hello everyone, this is Nandita from second year IT. Today I am going to discuss about sum of subsets problem in backtracking. Backtracking is one of the algorithm design technique. By using this technique for a given problem, we have to find out all the solutions. So now we are discussing one of the application of backtracking. Sum of subsets problem in backtracking. Suppose we are given n distinct positive integers or numbers. So these numbers are called weights. Now we have to find out all combinations of these numbers whose sum is capital M. This is called as the sum of subsets problem. Suppose n is equal to 6. That means we are giving 6 positive numbers. That positive numbers are called weights. And capital M is equal to 30. And now W of 1 to 6. So that weights are represented by a weight vector W of 1 to 6 is 5, 10, 12, 13, 15, 16. So now we have to find out all combinations of these numbers whose sum is capital M. The solution vector is represented by X. Here X is equal to x1, x2, x3, x4, x5, x6. Because 6 positive numbers are there. The element xi of the solution vector is either 1 or 0 depending on whether the weight wi is included or not. Here xi is equal to 1 means its weight can be considered in the solution vector. Here xi is equal to 0 means its weight cannot be considered in the solution vector. For a node at level I, be the left child corresponding to xi is equal to 1 and the right child corresponding to xi is equal to 0. Here the left child corresponding to xi is equal to 1 and the right child corresponding to xi is equal to 0. And now coming to the bounding functions. Bounding functions are used to kill the live node. Here sigma I is equal to 1 to k wi xi plus sigma I is equal to k plus 1 to n wi is greater than or equal to m. Sum of this quantity is greater than or equal to m, then by using bounding functions we kill that node. And coming to this, sigma I is equal to 1 to k wi xi plus weight of k plus 1th object is less than or equal to m, and this node can be added to solution vector. The state space tree can be drawn by using this following technique. Here sigma wi xi is nothing but weight vector and k is nothing but weight number in w of 1 to n, and here sigma wi is nothing but sum of weights of all n objects. Here left hand side x suffix k is equal to 1. Here right hand side x suffix k is equal to 0. If x suffix k is equal to 1, sigma wi xi plus wk comma k plus 1 comma sigma wi minus wk. If f suffix k is equal to 0, sigma wi xi comma k plus 1 comma sigma wi minus wk. Now coming to the example, draw the state space tree for m is equal to 35 and w of 1 to 5 is equal to 20, 18, 15, 12, 10. By using this technique, we have to draw the state space tree for the problem. Initially, we do not add any object into the solution vector. So the sum of the weights in the solution vector is 0. Now we have to consider the first object. And this is sigma wi is nothing but sum of the weights in the weight vector. Sum of the weights in the weight vector. That is 20 plus 18 plus 15 plus 12 plus 10 is equal to 75. K value is equal to 1. So we have to consider the first object, its value. x1 is equal to 1. This is nothing but k value is equal to, this is nothing but k value is equal to 1. After adding the first object weight, 0 plus 20, that is equal to 20. 1 plus 1 is equal to 2. 75 minus 20 is equal to 55. And again, x2 is equal to 1, x2 is equal to 0. 20 plus 18 is equal to 38. 2 plus 1, 3. And again, 55 minus 18 is equal to 37. Then x3 is equal to 1, x3 is equal to 0. Here the third object x3 is equal to 1. 38 plus 15 is equal to 53. And 3 plus 1 is equal to 4. 37 minus 15 is equal to 22. And coming to this, x3 is equal to 0. Here sigma wixi. So 38 comma 3 plus 1 4 comma 37 minus 15 22. Here 53 is greater than 35. So now we have to kill the node. And coming to this, 38 is greater than 35. So now we have to kill the node. And moving to this, consider the second object x2 is equal to 0. 20 comma 2 plus 1 3. 55 minus 18 is equal to 37. Again x3 is equal to 1, x3 is equal to 0. 30 plus third object, 30 plus 15. 20 plus 15 is equal to 35. 3 plus 1, 4. 37 minus 15 is equal to 22. Here m is equal to 35. So this is the solution 1. And moving to this, 42, 32 is greater than 35. So we have to kill this node. And coming to this, up to this point 5 objects are completed, but it does not lead to the solution. So I have to stop that node without expanding. And by doing in this way, we have to complete the state space tree. After completing the state space tree, we get 2 solutions. And this is the solution 1. And this is the solution 2. Solution 1 is equal to 20 comma 15, that is x1 comma x3, that is 1 comma 0 comma 1 comma 0 comma 0. Solution 2, that is 15 comma 10, that is x3 comma x5, that is 0 comma 0 comma 1 comma 0 comma 1. So these 2 solutions are represented in the state space tree. Thank you.